Let's look at how to make a graph using Microsoft Excel. And just like in your lab, we're going to graph two sets of data. So where you start is you need to make three columns with your data. The first column will have the data for the x-axis, which in this case is sucrose concentration. Notice I've put a label at the top of the column that contains both the value and also the units in parentheses. Then in the next two columns, I put the two sets of data that I'm putting on the y-axis, and just make sure that since we're graphing percents here, don't put the percentage symbol after the numbers, just type in the number that you'll be using. The next step is to click on the Insert tab up top. You highlight your data, and then you come over here to the left of the middle, and this bottom option in the middle, this is for inserting a scatter plot. So you click on the down arrow, and you want to select the option here at the top left, and that will insert a scatter plot. So here's your graph. You can make it bigger if you'd like. And now let's walk through how to format this graph. You can see the legend on the bottom. This tells us the blue dots are the data for the red potato. The orange dots represent the data for the baking potato. So let's start out by making a title. The easiest way to change the title is you click on where it says chart title. Then you can double click and highlight the title that's there and just type over it. And we'll just call this determining the water potential of potato cells, and you'd want to format your title correctly with capitalizing the major words. You want to make sure that the title is descriptive. So now we have a title there. Now we need to have some titles and labels for the x and the y axis. Notice the numbers are plotted, but there aren't any titles there. So if you go up to the top left and click Add Chart Element, we can add axis titles. So primary horizontal, that will be change in mass. Well, actually, the horizontal, that's concentration. And in parentheses, always put your units. So sucrose concentration, parentheses, molarity. For the y-axis, let's label that. Notice here you could also change the chart title off of this menu, and you could also change the formatting of the chart title if you'd like. So back to axis title, primary vertical. Just double click to highlight that so you can type in the box. Change in mass, and we're looking at percent change in mass. The next thing I'd like you to do is to insert trend lines. So you click on one set of data. So let me go to the baking potato data. I hover over one of the points and right click with my mouse, and you go to the option for Add Trend Line. And when you add the trend line, for this lab I want you to add a linear trend line. And if you come down to the bottom, I want you to click Display Equation on the chart, display the R-squared value on the chart. And what you see now, and you can move this so it's not covered up by the line, but what you see first of all is the equation for the line. That will be important as you're calculating the water potential of the cells, and also the R-squared value. The R-squared value tells you the correlation of the data with the actual data points. My R-squared value is 1 because I made up these data points and they ended up fitting perfectly on the line. Your R-squared value should not be 1. You should find that your line of best fit does not perfectly go through every one of the data points. So your R-squared value would be less than 1. Basically, the closer the R-squared value is to positive 1 or negative 1, the more closely the data points fit the line, to where an R-squared equals 1 means the points are directly right on the line. If you have an R-squared value of 0.8 or higher, that's generally pretty good. Let's click on the other set of data and also insert a trend line. Display R-squared value, display equation. Those show up. I'm going to move this. Notice how I'm moving it so that the equation isn't on top of the line, but I want it near the line that it's actually referring to. Something else you'll notice is that on the bottom of the graph in your legend, you now have extra entries in that legend to reflect the line of best fit. You don't need that because that's repetitive. So if you just click on those little titles, click once to highlight the whole legend, click again to highlight the individual title, go ahead and delete it. And then on your legend, if you'll format the legend put it to the right of the graph. This is your graph. This is a graph that would be acceptable for use in your lab report that you turn in. If you copy the graph, if you just highlight the graph like this, and then you can copy, then go over to Microsoft Word where you are putting together your lab report, and you can paste this directly into the lab report. Just to give you a better idea of what your data might look like, I changed the numbers a little bit so they don't fit perfectly on these lines. And you can see we have our lines of best fit, and you have the data points that are close to the lines but not directly on them. And notice what that did to the R-squared value. We now have an R-squared value down here of 0.993 and up top here of 0.9829. That's still very close to 1, and that tells us that our data points are still close to the line. The average distance between the points and the line is fairly low, and you'll find as the average distance between the points and the line increases, that R-squared value will go closer to 0.